Red dwarf stars burn hydrogen so slowly that they can maintain stable conditions for hundreds of billions of years, providing enormous timescales for life to evolve and civilizations to develop. G-type stars like our Sun offer stable conditions for billions of years, while K-type stars provide intermediate lifespans with reduced harmful radiation. These longer-lived stellar systems create more opportunities for intelligence to emerge and survive long enough to develop detectable technologies. The mathematical analysis extends beyond simple signal detection to encompass techno-signature probabilities. Scientists calculate the likelihood that advanced civilizations would produce detectable modifications to their environments, including atmospheric pollution, stellar engineering projects, or large-scale energy consumption. These calculations suggest that technological civilizations should produce observable signatures that current detection systems can identify. The probability models indicate that civilizations capable of interstellar communication would also likely engage in activities that create detectable techno-signatures. The probability calculations account for the fact that civilizations might use communication methods that differ from human expectations. AI systems can identify artificial signals regardless of their specific format or encoding scheme, increasing the likelihood of detecting communications that use unfamiliar protocols. The expanded frequency ranges monitored by modern telescopes ensure that signals using different portions of the electromagnetic spectrum cannot escape detection. These factors combine to create detection probabilities that exceed any previous period in human history. The mathematical models also incorporate the possibility that multiple civilizations might exist within our detection range. The sheer number of potentially habitable planets suggests that intelligence might be relatively common on cosmic scales. If even a small fraction of habitable worlds develop technological civilizations, the galaxy could contain thousands or millions of detectable societies. This abundance increases the probability that at least one civilization will be discovered within the foreseeable future. Current data suggests that we are living during the most promising period in human history for making contact with alien intelligence. The convergence of multiple factors creates unprecedented opportunities for discovery. The number of known habitable planets has increased dramatically since 2009. Detection capabilities have improved through AI integration and advanced telescopes. The definition of habitable conditions has expanded to include previously overlooked environments. The duration of systematic searches has reached the point where statistical models predict that discoveries become increasingly likely. The statistical frameworks reveal that current detection capabilities have reached a critical threshold where discovery becomes mathematically probable rather than merely possible. The combination of expanded search targets, improved detection methods, and continuous monitoring creates conditions where the probability of finding extraterrestrial intelligence increases with each passing year. The mathematics suggests that we have moved beyond the question of whether we will find alien intelligence to the question of when that discovery will occur. These calculations have gained particular urgency as recent observations have produced signal detections that challenge the boundaries of what researchers previously thought possible. Recent signal detections and near misses. The most significant signal detections in SETI history demonstrate both the promise and the challenges of identifying genuine extraterrestrial intelligence. Each major discovery has brought researchers closer to understanding what alien communications might look like, while revealing the extraordinary precision required to distinguish artificial signals from natural cosmic phenomena and terrestrial interference. The WOW signal remains the most famous detection in SETI history, captured on August 15, 1977, by the Big Ear radio telescope at Ohio State University. The signal originated from the constellation Sagittarius and reached an intensity 30 times stronger than typical background noise. Jerry Eman, the astronomer who discovered the signal while reviewing computer printouts, circled the alphanumeric sequence 6EQUJ5 and wrote "WOW" in the margin, giving the detection its enduring name. The signal lasted exactly 72 seconds, matching the duration expected for a transmission from a fixed point in space, as Earth's rotation carried the telescope's beam across the source location. The characteristics of the WOW signal suggested artificial origin in several important ways. The transmission occurred at 1420 MHz, the natural frequency of hydrogen atoms, and a logical choice for interstellar communication, because it represents the most abundant element in the universe. The signal's intensity peaked and faded in a pattern consistent with a narrow beam transmission from a distant source, rather than the broad-spectrum emissions typical of natural astronomical phenomena. The frequency remained remarkably stable throughout the 72-second detection period, showing none of the drift or variation expected from natural radio sources like pulsars or stellar emissions. Despite decades of follow-up observations, the WOW signal has never been detected again. Researchers have pointed radio telescopes at the same region of sky hundreds of times, searching for any repeat transmission or additional signals from the same source. The absence of follow-up detections has led to various theories about the signal's origin, including the possibility that it represented a one-time transmission from an extraterrestrial civilization or a brief malfunction in a natural astronomical source. The signal's unique characteristics continue to make it the benchmark against which all subsequent SETI detections are measured. More, recent discoveries have provided new examples of anomalous signals that challenge conventional explanations. The Canadian Hydrogen Intensity Mapping Experiment detected an unusual radio transient designated Chime J1634+44 that exhibited structured patterns unlike typical fast radio bursts. The signal showed mathematical sequences that repeated in precise intervals, with characteristics that suggested possible artificial modification of natural radio emissions. The detection represented a new category of radio transient that displayed both the intensity of natural cosmic phenomena and the structured patterns that might indicate technological manipulation. The Chime detection demonstrated how modern AI systems can identify subtle patterns in radio signals that human researchers might overlook. The artificial intelligence algorithms recognized mathematical relationships in the signal timing that were statistically unlikely to occur through random processes. The structured nature of the transmission, combined with its unusual frequency characteristics, placed it in a category of detections that warrant continued monitoring and analysis. The signal's properties matched several theoretical predictions for how advanced civilizations might modify natural radio sources to encode information. These significant detections have revealed common characteristics that may indicate artificial origin. Both the WOW signal and the Chime transient exhibited precise frequency control that distinguished them from natural radio sources. The signals maintained stable characteristics over their duration, showing none of the random variations typical of cosmic phenomena. The mathematical patterns embedded within these transmissions suggested deliberate structure rather than the chaotic emissions produced by stellar processes or galactic events. The verification procedures developed in response to these detections have become increasingly sophisticated. Modern protocols require multiple, independent confirmations before any signal receives serious consideration as potentially extraterrestrial. The procedures include cross-referencing with satellite tracking data to eliminate human-made interference, coordinating observations across multiple telescope facilities, and conducting detailed analysis of signal characteristics to distinguish between artificial and natural sources. These verification steps help prevent false alarms while ensuring that genuine signals receive appropriate attention. The pattern of near-miss detections has provided valuable insights into the nature of potential alien communications. Signals that initially appear artificial often reveal natural explanations upon closer examination. But each detection refines our understanding of what genuine extraterrestrial transmissions might look like. The accumulation of anomalous signals has created a database of characteristics that help researchers distinguish between natural phenomena and possible technological signatures. Recent signal detections have also highlighted the importance of continuous monitoring rather than isolated observations. The WOW signal's failure to repeat has led to questions about whether it represented a genuine extraterrestrial transmission or a one-time natural event. Modern SETI programs maintain continuous surveillance of priority targets, ensuring that any repeat transmissions or follow-up signals can be detected and analyzed. This approach acknowledges that alien civilizations might use communication protocols that differ significantly from human expectations. The false alarm incidents that have occurred throughout SETI history have actually strengthened the field by forcing researchers to develop more rigorous detection standards. Each misidentification has led to improved filtering algorithms, better coordination with aerospace agencies, and more sophisticated verification procedures. These lessons have created detection protocols that can distinguish between genuine extraterrestrial signals and the various forms of interference that can mimic alien communications. The analysis of these signal detections has revealed that confirming extraterrestrial intelligence will likely require multiple indicators rather than a single definitive characteristic. Future discoveries may combine elements observed in historical detections, such as the frequency precision of the wow signal and the mathematical structure found in recent transient discoveries. The sophisticated processing systems now monitoring these signals operate through complex protocols designed to identify exactly these types of multi-layered artificial signatures. The AI detection protocols. These detection capabilities depend on AI protocols that have evolved far beyond simple signal identification into comprehensive analysis frameworks that process radio data in real time. The systems follow multi-layered filtering procedures that eliminate terrestrial interference and natural cosmic phenomena before identifying potential extraterrestrial communications. The first filtering layer removes obvious human-made signals from satellites, cell phone towers, radar installations, and communication networks that might contaminate astronomical observations. This elimination process happens automatically as radio waves reach Earth, separating artificial terrestrial sources from legitimate cosmic signals. The second filtering layer identifies natural astronomical phenomena like pulsar emissions, stellar radio bursts, and background radiation that originate from known cosmic sources. The AI systems maintain detailed databases of cataloged radio sources, each with characteristic signatures that allow for immediate identification. When signals match these known patterns, the system classifies them as routine astronomical phenomena and continues monitoring without human notification. This filtering process prevents researchers from investigating countless natural signals that would otherwise overwhelm detection systems. Pattern recognition algorithms form the core of AI detection protocols, searching for mathematical sequences and structured communications that indicate intelligent design. These algorithms analyze signal timing, frequency patterns, and amplitude variations to identify artificial modifications that suggest technological origin. The systems recognize mathematical progressions embedded in signal characteristics, including sequences that would be difficult to produce through natural processes. The algorithms can detect structured information content that follows logical rules, even when the specific encoding methods differ from human communication protocols. Engineers at the SETI Institute use GPU-accelerated AI systems to process massive amounts of data from the Allen Telescope Array in real time, filtering out noise to highlight potential signs of intelligent communication. These machine learning models have been trained on billions of known signal types, enabling the systems to distinguish between artificial and natural sources with remarkable accuracy. The training process involves extensive databases of pulsar emissions, stellar radio bursts, atmospheric interference, and equipment malfunctions that create false signals. The systems develop understanding of signal characteristics through exposure to millions of examples of both natural and artificial transmissions. The verification procedures require confirmation from multiple independent AI systems before human researchers receive notification of potential extraterrestrial signals. When one AI system identifies a promising detection, it automatically transmits coordinates and signal characteristics to partner installations across the globe. These sister systems orient their telescopes toward the same location and conduct independent analysis of the detected signal. The verification process requires at least 3 separate AI systems to confirm signal characteristics before triggering human notification protocols. The automated cross-referencing with satellite tracking data eliminates human-made interference that might otherwise appear to originate from cosmic sources. AI systems maintain real-time connections with aerospace agencies, satellite tracking networks, and military communication systems that provide information about all artificial objects in Earth orbit. When potential signals are detected, the systems automatically check whether any known satellites or spacecraft could have produced the observed radio emissions. This cross-referencing happens within seconds of initial detection, preventing false alarms from terrestrial sources. Signal classification follows established methodologies developed through programs like SETI at Home and Breakthrough Listen, which have processed petabytes of radio telescope data using distributed computing networks. The systems evaluate signal strength, duration, frequency stability, and structural complexity to assign confidence scores that indicate the likelihood of extraterrestrial origin. Signals that exceed predetermined threshold values in multiple categories trigger immediate human notification protocols. The threshold system prevents researchers from investigating every minor anomaly while ensuring that potentially significant signals receive prompt attention. The AI systems are programmed to recognize not just human expectations of alien communication, but entirely unfamiliar forms of intelligence that might use communication methods unknown to terrestrial science. The algorithms search for any form of artificial structure in radio signals, regardless of whether these patterns match human preconceptions about extraterrestrial communications. This approach acknowledges that alien civilizations might use encoding techniques, frequency modulation methods, or signal structures that differ significantly from human technology. Backup systems ensure that no potentially significant signal is lost due to processing errors or equipment malfunctions. Each AI installation maintains redundant processing units that independently analyze all incoming data streams. When primary systems experience failures, backup units automatically assume processing responsibilities without interruption. The backup systems maintain complete records of all signal analyses, allowing for retrospective investigation of any data that might have been missed during equipment problems. The protocols include specialized algorithms designed to detect signals that are deliberately weakened or disguised to avoid detection by other civilizations. These detection methods search for subtle patterns hidden within apparently natural radio emissions. The systems can identify artificial modifications to pulsar timing, deliberate frequency modulation of stellar radio bursts, and encoded information embedded within cosmic background radiation. The verification protocols require signals to maintain consistent characteristics across multiple observation sessions before classification as potentially extraterrestrial. The systems track signal stability over time, documenting any changes in frequency, amplitude, or timing that might indicate natural rather than artificial origin. Signals that demonstrate consistent artificial characteristics over extended periods receive higher confidence ratings and priority attention from human researchers. The AI detection protocols represent a fundamental transformation in humanity's approach to finding extraterrestrial intelligence. These systems combine unprecedented processing power with sophisticated pattern recognition algorithms that can identify artificial signals regardless of their specific format or encoding scheme. The protocols ensure that no potential extraterrestrial communication escapes detection while eliminating false alarms that might otherwise overwhelm human researchers with irrelevant data. The moment these systems achieve their ultimate goal and confirm genuine extraterrestrial intelligence, they will trigger response procedures that have been carefully planned for decades. First contact protocols in the AI age. These automated systems immediately activate established protocols that have been refined through decades of international scientific cooperation. The notification process begins within seconds of signal verification, transmitting detailed information about the detection to predetermined recipients across major observatories, research institutions, and scientific organizations worldwide. The automated systems ensure that no critical information is delayed due to human communication failures or time zone differences that might otherwise compromise the verification process. The verification procedures require multiple independent confirmations before any public announcement can be made. According to the Declaration of Principles concerning the conduct of the search for extraterrestrial intelligence, researchers pledge to publicize verified detections promptly and engage international bodies in the confirmation process. This approach ensures that the scientific community receives complete information about the detection, including the basic data, verification process, conclusions and interpretations, and the detected information content of the signal itself. The verification process involves at least 3 separate AI systems confirming the signal characteristics, followed by human expert analysis that examines every aspect of the detection for possible terrestrial explanations. International agreements governing the response to confirmed extraterrestrial contact have been established through organizations like the International Academy of Astronautics and the SETI Institute.